the last part of modeling, or of trigonometry, is modeling. So we're going to be looking at real world story problems, and then we're going to be graphing them, we're going to be writing equations, and we're going to be able to answer questions from them. So this is just your very traditional problem that you're going to see quite often. It's a Ferris wheel problem. So we have this Ferris wheel, the diameters, they're telling you information that you need, like the diameter is 120 meters, how long it takes to make one rotation. What that's telling you is how long it takes for one cycle to complete. So what is that telling you? That's the period. The period is 30 minutes. That's going to be important when we're writing our equation. You board from a platform which is 2 meters above the ground. Again, gives you some height values. And then can you find the height above the ground as a function of time? So I'm asking you to write an equation for the height based on its time. So again, I specifically pulled this out right away because this is important. You have to look for how long does it take for one full cycle of whatever it happens to be that you're looking for. And then we start looking at our heights, because what we're doing is we're modeling the height of this function. So we know that from the bottom, this here is 2. This from here to here is 120. Therefore, I know the total height is 122. So that's an important feature in and of itself. But what you might want to do is sometimes it helps to sketch the graph. So that way you kind of have an idea of where you're at. Now this says P sub 0. So this is like that initial height. So our initial height is how far off the ground? 2. So therefore, when I sketch this graph, initially we have a height here of 2. So this is at 2. And then here it gets taller, and then the height is taller here, and the height is taller here, height is taller here, super tall here. This is the tallest height. The tallest height is therefore going to be, say, right here, and that is at 122. And then it gets shorter and shorter and shorter and shorter and shorter until it comes back down here at 2. What you're going to notice is these are equally spaced apart, at least they should be. So halfway in between here, there's a value, halfway in between here, there's a value. And then it goes back again. So from here, the lowest, it gets taller and taller and taller until it hits its max, and then it hits its min, and then it hits its max, and then it hits its min. This is that cyclic function. So based on the fact that this is a cyclic function, we are able to write our equation. So there's a few different things that you can look for to try to find things out. Some people like to list everything out. So we know the highest is 122, the lowest is 2, and based on that information, you can find your midline. So you can just do it from this data here. Where does the midline fall? Halfway between the lowest and highest. How do I find a value halfway between? Add them together, divide by 2. So 122 plus 2 divided by 2. So 124 divided by 2 is 62. So that's where my midline is. And that tells me something specific in my equation. You can also see it on here. Okay, what's halfway in between these? And then find that as well. Additionally, once you know where your midline is, that midline is really helpful because you know from the midline to the max and the midline to the min, those two are the same. Therefore, you know your amplitude, your A value. So from your midline 62 down to your min of 2, that's a distance of 60. Or from the 62 up to the 122, that's 60. Or you can subtract these two values, 122 to minus 2, that's 120. So that's the total distance, and then cut that in half. So there's a lot of different options for finding it, but once you find that midline, you can very, very quickly find your A value. Additionally, we know the period. We have this formula, P equals, this is a sine and cosine function because it has this wave. So that's 2 pi over b. So I'm giving you P. So we legitimately set up an equation. So 30 equals 2 pi over b. Can't have b in the bottom to solve. Multiply both sides by b. So therefore, divide both sides by 30. Sorry, I ran out of space here. We get 2 pi over 30. So therefore, if I simplify that, that's just pi over 15. That's b. Why is that important? Because that's in our equation. This tells us the length of one cycle. This is the b value in our equation. And if you remember, b is the number of cycles that fit between 0 and 2 pi. This is kind of odd. There's pi over 15 because these are real numbers. They're normal, typical numbers, 5s and 15s and 37s and 122s. They're not pi over 6s, pi over 4s. So that's why this b value is kind of weird. So from here, I'm going to go back to my picture so we can try to figure out what equation we want to do with this one. So I know that one full cycle is 30 minutes. So this is 0, this is 30. This is 15. Remember, everything's halfway. So halfway between 0 and 15, that's 7.5. That is one of the nice things about dealing with regular numbers, is you can easily find those values in the middle. And then we have halfway between, so 22.5. Okay, so now what I can do is I can write my equation. It is up to you whether you want to write a sine equation or a cosine equation. I'm going to start with a cosine equation, and then I'm going to do a sine equation, because they're super easy. Once you can do one, you can do the other one. So I'll explain why in just a second, why I'm picking cosine. But unless I tell you, it doesn't matter which one you use, because they're just a horizontal translation of each other. So transformation form, y equals a cosine b x minus c plus d. So those are our letters that we use. Algebra, we used h and k, no matter. So a, amplitude 60. We found that already. But I'll talk about that in a second. So amplitude 60. Cosine b, that's what we found here. So that's pi over 15. X minus c. Okay, so this part here, cosine, is where my max is on my y-axis, but my max isn't on my y-axis. Where's my max at? It's at 15. Since my max is at 15, I have to shift this. This is shifted to the right 15, so therefore it's minus 15. Because again, the max value for cosine is your y-intercept. How far away from the y-intercept is it? 15 units to the right, which is why it's x minus 15. And then d is my vertical shift. That is always your midline. And that's your equation, just based on the information. Now, if I instead were to make this cosine value a negative, here's what I mean. Cosine has a max value, and then down to the min, and then the max again. But if we reflect that over the x-axis, instead of it starting on the max value, it's going to be starting at the min value. So an exact value of this without a horizontal shift, all I need to do is have a negative a value. That negative a value reflects it over the x-axis, because this is your y value, so it reflects over the x-axis. Then there is no horizontal shift, so then it would just be x. The reason I'm showing you this is IB may tell you that there is no c. If there's no c, you have to do a cosine equation, and therefore it doesn't have a shift, and the only way that happens is if you do a reflection. Okay, so those are the cosine ones. I can also do a sine. With a sine function, remember parent function for sine, midline, max, midline, min, midline. So it starts at the min and goes up. If it were to start at the min and go down, that again is a reflection, just like for the cosine function. If it starts at the min, so cosine, max, max, min, midline, midline. So if instead it starts at the min and goes min, max, min, midline, midline, this has that negative multiplier. So same thing with sine. Instead of going from the midline to the max, if it went from the midline to the min, that would be a negative multiplier. But what I need to do is I look right here. That's where my midline is. This is my midline. So therefore, this is going from my midline going up. So this is the horizontal shift for a sine function. If I did this one over here, then it would be a negative multiplier, and then I'd use that 22.5. So for a sine function, it's still 60. It's the sine of pi over 15 x. Now my horizontal shift again is from the midline going up, so that's the 7.5 plus 62. So that's how you write a trig equation for either sine or cosine, whichever one you feel comfortable with. Okay, so let's go into the next one. So the next one is going to have us calculate this information. So along the way that we're going to find it, we're going to write our equation, and then we're going to actually solve for some other things with it. So we have a fisherman, he's got a boat in the harbor. We're talking about the depth of the water, and this is the number of hours after midnight. This is kind of nice because it starts at 0 there. So what I want you to do is I'm going to have you pause the video right now, and what I want you to do is see if you can find these values right here. So A, B, C, and D. My recommendation for you before you do anything else is figure out where your midline is, and then that usually can help you. So pause this and go ahead and see if you can solve for A, B, and C. Okay, so if I want to find my midline, I have to find where, if I want to find my midline, I have to figure out where it is halfway between my max and my min. So therefore, I'm just going to draw this and kind of like eyeball it. So it looks like, okay, this is like a full box and a half, full box and a half. So it's kind of looking like that's where my midline is. So that's how I can visually try to represent it. It's not always ideal though. The other thing is if we're trying to find a value in between, remember we're averaging them. So it's halfway between 8 and 2. How do I find a value in between? Add them together, divide by 2. So therefore my midline here is at 5. It's exactly at 5. And once I know that, I can very quickly find my amplitude. So from 5 to 8, what's that? That's 3. Okay, now also because I have the midline, I can figure out what my length of one cycle is. So I can go from midline to 2 midlines. That horizontal length is one cycle. It looks like it's going halfway between 0 and 2, so that's at 1, and it looks like it's halfway between 12 and 14, which looks like it's at 1. Not perfect, but that's kind of what it looks like. Easier one is to go to max, from max to max. Max here looks like it's at 4. Max here looks like it's 16. Therefore, what's the distance between between 4 and 16? That's 12. So the period for this is 12. Period is 12. That's not B, that's P. I'm going to want to do a cosine equation. So I'm going to have to figure out where my horizontal shift is. So with our cosine equation, we need to figure out where does our max shift. So my max is over here at 4. Therefore, my C value is going to be 4 because it's going to go 4 to the right. I could also say 16, or I could make it negative and say 10, or negative and make it 22. That would be if my A value is negative, of course. And the vertical shift is what we actually found first. That's the D value. That's what we call it at least. So that's at 5. Again, that's that midline piece. Okay, before I do anything else with writing my equation, I need to keep going with part B here. So with part B, I gave you the period. Period equals 2 pi over B. So 12 equals 2 pi over B. Multiply both sides by B. P equals 2 pi over 12, which simplifies to pi over 6. Pi over 6 is going to be our B value. Again, trying to really hit home that P and B are different. I'm just scared that a lot of you on your tests, when they ask for the P or they ask for the B, you're going to give vice versa. So just making sure that you really understand the difference between those. Okay, so now that we came up with those, now I'm going to have you write the equation. So pause it again and go ahead and write your equation. So M equals A, they said a cosine equation. That's how we found our C value, our B, and then, not X, they used H. Minus 4, because it's 4 to the right, plus 5. So that's our equation. So now what we're able to do is we're able to now use this equation to analyze different pieces. So like here, they want the depth of the water at 9:30 a.m. So 9:30 a.m. looks like it's right about here, because right in the middle is 9, so in between 9 and 10. So what I can now do is I can use my equation to help us with this. So in order to do that, what you're going to do is you are going to legitimately just use your calculator, and you're going to substitute in place of H what? That 9:30, right? But I can't put 9:30 in. How do I put that, seeing that my X value is defined as hours? Good, 9.5. So you're going to substitute 9.5 in for H. So type this in your calculator. It takes a little bit of time to type this in. So see if you can get the answer out. So pause it, see if you get the right answer, and I'll explain a couple of things that you have to be careful about. Okay, so when you type that into your calculator, you get 2.10 meters. That's our answer. So did you get it? If you didn't, here are a few things that might have happened. First thing, what mode are you in? Our period we're using is 2 pi. If we were using 360, it would be in degrees, but since I'm using 2 pi, the mode of your calculator has to be in radians. So that's the first thing to check, is check your mode. Second thing to check is when you type this into your calculator, the cosine is taking all of this. So technically there's an extra set of parentheses here, and you have to be careful because of this fraction. So when you type into your calculator, 3 cosine, a parenthesis opens. Open up another parenthesis. and then do pi over 6. Those are parentheses around it. Open up another parenthesis, h minus 4. So making sure that you get those extra sets of parentheses, and then after that cosine piece, because you know how it opened up the parenthesis, then you had the parenthesis pi over 6 parenthesis 8 minus 4 parenthesis, and then close that final parenthesis with your cosine, and then plus 5. If you're still not able to type it in, take a look at your partner's calculators and make sure you're using your own calculator too, because this is something that will be on a calculator test, and they want to make sure that you actually know how to type this in your calculator correctly. So don't be afraid to do that. Okay, then the last part is Ben's boat can only get in and out of the harbor when there's at least 4 meters of water at the mouth of the harbor. And then Ben sleeps until 10 a.m. Find the next time you can go fishing. So this is like a legitimate question. So your boat, if it's too deep, it can only go out during high tide maybe, or during certain times. So this would be a piece that you then have to be able to solve for. So with this one, what we're trying to figure out is when can you go out? Well, where does the 4 go in for? 4 goes in for your m value. So what we're going to look at is figure out where does 4 equal 3 cosine pi over 6 h minus 4 plus 5. Okay, so that's what we're solving right now. Again, completely calculator based. So into your calculator, put a 4 into y1, put this into y2. Again, typing very carefully with your parentheses around this, and then you're going to intersect those. So remember, calculate, intersect. So go ahead and take a few moments to solve that and find the intersection. So when you solve this, you get 12.35 hours. Now, again, be careful with time because it's not 12:35. You have to convert the 0.35 hours into minutes. So that way you can give an actual time. So 0.35 times 60. So therefore, this is at 12:21 p.m. because it's 12 hours past midnight. So that's the next time he can go fishing. Another thing that they could ask for instead of like when could he, like during what times could he get out? So figuring out when is it more than, what was it, 4 meters? Yeah. So when is it more than 4 meters? So this is when it's 4. That's what you did, is you set it equal. And then you found where it intersected. He slept until 10. So you were looking at this point here. So he could go out anytime between that time and this time. And then again, later on in this direction too. So those are kind of some of the things that they could ask you about. Now, with this being on a calculator test, there's one other trick that I want to show you quickly. With part F here, finding the depth of the water at 9:30, which of course is 9.5, what you could do is, because you're going to have to type this equation into your calculator for part G, you can use this equation. So having this in your calculator, delete out the y equals 4 equation. We just want this one. What you can then do is you can go to second trace, just like you do for intersect, but now what you can do is a value. So second trace, and then go down to value. I think it's the first one. And then what you can do is it takes you to the graph, and then you just type in 9.5 and hit enter, and it will spit out what the y value is. So since you already have to use your calculator, you might as well use your calculator. So it saves you that time. It saves you a little bit of time on your test because you already are going to have to be graphing this one in there. Okay, and then our last example. So what we did is we did 3 different scenarios. The first one was based on a picture. The second one was based on the graph. And the third one is based on a scenario. So these are kind of the 3 different things that you could see. As you saw in the first one, I did a quick sketch of this so that we could see what the graph looked like. This one, we already had a graph. For this one, you may want to sketch your graph because by sketching this graph, it's going to give you a really good visual of what you know about it. You don't have to. You can find all of your data in here, but it is something that can be super helpful. So again, I'm going to be finding A, B, C, and D. And then they tell us this. January is 1. So this is like the coordinate point 115. So when we graph it at 1, it's at 15. At 2, it's at 14. At 3. So I'm just kind of plotting those points along the way. Scale this better than I did, count it by 5s maybe. But it'll give you a nice graph, and you're going to notice it does something like this. It's not perfect, and it's not exactly like this, but it's not perfect. But you see how you can see that it's a sine function, and we tell you right here that you're going to use a sine graph. So you can see that it's the sine function that's in there. You can find your lowest value, that's here. You can find your highest value, that's here. So therefore, you know this is going to repeat. So after December, it's going to get a little colder, and then it's going to get a little warmer, and then it's going to get a little colder. So it's going to keep repeating over the years. So that helps you then to be able to write the equation. So I want you to see if you can write this equation to find A, B, C, and D without my help, and then I'm going to go through it with you. Okay, as always, I really like to find my midline. And again, the data is not always going to be exact because it's real world data. So we're going to get approximation. So that's why it says it's approximately equal to. I mean, think about, like, February is not always the coldest month. Maybe some years January is, other times maybe March is. And just like July isn't always the hottest month, maybe it's August. So it's not perfect, but it should give us a good roundabout idea of how things are going to lie. So finding that midline, these are the two values. 14 is the low, 27 is the high. Midline is halfway between them. So 14 plus 27 divided by 2. When we do that, we get 20.5. Our amplitude, find the value from the midline to the max, midline to the min. So therefore, how far is it from 20.5 up to 27? Our A therefore is 6.5. The period, how often does this repeat itself? Now, you can think about how far is it between February and July, or think about it a little bit more logically. How often do our temperatures repeat themselves? Every 12 months, right? That's the period. The period is 12 months. Therefore, to find your B value, it's 2 pi over 12. So multiply, sorry, let me start that again. Jumping ahead of myself here. Period is 12, so therefore P equals 2 pi over B, so 12 equals 2 pi over B, multiply both sides by B. B is pi over 12. Okay, so you have your B value, you have your A value. What's the midline again? That is your vertical shift, and that's your D. So you have A, B, and D. Now you just have to find your horizontal shift of C. So to find your horizontal shift of C, you know that your low value is here at 14. You know your high value here is at 27. So this was 2. So 1, 2, 3, 4, 5, 6, 7. So what's halfway between 2 and 7? 4.5. So that's where the midline is going to be, because again, this was at 2, and this one here was at 7. So where's halfway between there? That's at 4.5. So that's your horizontal shift. So that's your C value. So then you can write your equation. T equals A. Let's find our A value. A is 6.5. Sine, because it's the midline going up. If it was cosine, it would be at 7. But it's sine they asked for. B is pi over 12. And then we're not using X, we're using T. Minus C, which we just found was 4.5. And then our vertical shift was up here at 20.5. So that's how you go through those. So pictures, helpful, gives you an idea. It also gives you a nice visual as you go through. That would be my biggest recommendations when you do story problems.